Okay, so this is the first example in alkaline condition, so pay good attention. I'm going to go through this a little bit slower. You have to, like in acid condition, you added H plus. Here you have to add OH minus ions and water as required, if it's required. You need to add it to the less negative side, okay? Which means you need to increase decrease the charge by adding OH to the less negative side to make the charges equal on both sides. Okay, you'll only do this by practicing. When you practice more and more, you'll actually get better with this. Where to add the OH minus ions. Okay, there is another method for doing this. We'll go through that later on. Okay, let's go through this. Okay, I hope you watch this really carefully because it's different condition, alkaline condition. Okay, now H2O2, this being a peroxide, you got -1 on each oxygen. Now because there is 2 oxygen atoms here, the total oxidation state is -2 here, and then here it is +2, -2 here. However, notice that the oxygen is changing oxidation state from -1 to -2, so that has to be balanced first. Okay, so now you can see the total charge on the left is 2 times -2 -4, so you can see the total oxidation state change is from -2 to -4 on the right hand side. So that means you have to add 2 electrons onto the left. Now when you add this, check the number of atoms. 2 hydrogen, so the atoms and the charges are all balanced, so this half equation is done. So the key thing is to realize that this is a peroxide and it's -1 charge, and to see that that is getting reduced by gaining 2 electrons, and there is a total of 2 oxygen atoms, H2O2, that's hydrogen peroxide. So the total oxidation state is not -1, it's actually -2 for the 2 oxygen atoms. Okay, so this is key to actually balance this equation. This is really important. Then you look at the right hand side. First you balance this because that's changing oxidation state. I need to balance that oxygen, and then check what's the total oxidation state on the right hand side. Each oxygen has got -2. 2 times -2 is -4. So you can see that the total oxidation state change is from -2 to -4. That means you need to add 2 electrons on the left hand side. There is no need to add any water because the hydrogen and oxygen atoms are balanced. That's how it's done. Okay, so here for chromium 3+ going to +6 oxidation state here, right? So this means it's actually losing 3 electrons here. Okay, so that's the electrons done. Now check the oxygen atoms there, right? And the charges can be balanced. Now when I said less negative side, so you can see this is 3+ overall charge on the left hand side. On the right hand side, again I'm looking at the species charge on the species only, not considering this number. Okay, so the charge is -5 as you can see. So the total overall charge is -5 here, and the overall charge I have is +3. This allows me to actually decide on how many hydroxide ions to add on to the left. So going from +3 to -5, I can see that I need to add 8 OH minus ions, and that will take it from, so if you go +3 minus 8, that gives you -5, which is the same as that, right? So this allows me to do 2 things in one go. I'm also balancing the oxygen atoms, right? The hydrogen atoms on the right hand side. All that can be done in one go, right? Now there is hydrogen atom on the left, there is no hydrogen atom on the right hand side. Also notice there is a shortage of oxygen atoms, so that means I have to add water to the left hand side, and the easiest way to try first is to halve this number. There's 8 hydrogen, this is going to be 4 water, and then check the oxygen atoms. 4 oxygen here and another 4 here, that's 8 oxygen atoms. 8 oxygen atoms on the left hand side, 8 hydrogen atoms as well, 8 hydrogen atoms. That's okay. chromium, one chromium on each side. That's all right. So all balanced. Okay, check the charge as well. Overall charge now. +3, -8. That gives you -5. And here you have -2, -3. That gives you -5 overall charges. The charge is also balanced. So that all you have to now do is make the electron numbers the same. You got 3 electrons here, 2 electrons here. You have to make the electron numbers the same, and you know how to do this and come up with an overall equation. So now I'm going to I'll multiply that. Now I'm going to just tidy this up, add these two up, write an overall equation. So that is the overall equation for this. This equation is really important, where you will see this in transition metals when you learn transition metals in year 13, where green colored this ion is green colored solution that is oxidized to chromate ions with the color change from green to yellow. So as you can see, all these redox reactions come in different places when you learn year 13 content. So it's really good to have a good grip on this, so you can really understand lots of different topics, like storage cells, for example, that also has redox in it, transition metal titrations. So all of that, it's really useful to know how to balance these equations. So that's the first example in alkaline conditions done. I hope you can actually do the next one yourself, or at least try that one. So okay, pause this, have a go, and then check. It's alkaline conditions. Remember, you have to add OH minus ions. So that's alkaline conditions means OH minus and water if required. Okay, remember the steps. Look at the oxidizing and reducing, identify the atom that's getting oxidized or reduced, and make sure that you balance them first. Add the electrons, then add OH minus 1 to balance the charge, as well as the oxygen and hydrogen atoms. You may have to add water. So that is the steps to take. Okay, so let's have a look at the first one. See, first thing I check for is what's getting oxidized. So I focus on iron because that's most likely. So here you have 2 plus. Okay, so +2 here and +3. So add the electron first. Okay, so plus E minus. Now you can see this side overall charge now is -1, and you don't have no charge here, 0 charge. So I have to now add OH minus ions onto the left hand side. Now check the atoms, they are balanced, and the charge. So this half equation is done. And look at this O2. Be careful. This is 0 oxidation state, and this is -2. Okay, so that's going. Not only that, this is changing oxidation state. Then you have to balance this first. Remember, so you have to balance that. Now you can see the overall charge is -4 here. So this is where you have to be very careful. Okay, so 2 times -2 is -4. So it's going. This total oxidation state change is 0 to -4. So then I have to add 4 electrons to this to start with, right? Now as you notice, you have an overall charge of 4 -4 on this side. I only have 2 times -1. You have a charge of -2 on the left hand, on the right hand side. Like I said before, you need to add the OH minus ion to the less negative side. So I have to add 2 OH minus ions here, right? That means now I have hydrogen atoms here which are not balanced on the left hand side, so I have to add the water molecules to balance the hydrogen atoms, and hopefully the oxygen will balance itself out. Let's see. So I'm going to add H2O, and I have 2 hydrogen here, 2 hydrogen here, so let me try 2 here. Okay, now the hydrogen's okay. Oxygen, 2 oxygen plus 2 oxygen, 4, so that seemed to be okay. Check the charge. There's 4 negative charge, there is 2 minus and 2 minus, so this is also balanced now. So all that you have to look at now, 2 half equations, check the electron numbers, multiply that by 4 and add them up and write the overall equation. This is the overall equation. As you can see, there is 4 OH here, which cancels out with these 4. Also the electrons cancels out. You have the oxygen left, water still there. Okay, so just tidy this up. You can see that most things on the right gets cancelled. Hope that's okay. So move on to the next example. Again, alkaline condition. Stop, try for yourself. Okay, doing the top equation now. I added the oxidation number for manganese here, +7 +4. Now going from +7 to +4, you need to add 3 electrons to this. So this is gaining 3 electrons. Okay, so I added the 3 electrons. Now look at the overall charge of the species. -3 for 3 electrons, and then 1, that's -4 here. There is no charge on the left. Okay, so that sorry, on the right there's no charge, 0 charge. So remember I said less negative side gets this OH. To get the negative side up, so I'm going to put 4 OH minus on this side. Now check the hydrogen atoms. There is no hydrogen atoms here, so I have to add water. I divide that by 2 because it's 2, then that becomes 2H2O. Right, now check the atoms. 4 hydrogens, okay. Now 4 oxygen atoms plus 2, 6 oxygen atoms here, 6 oxygen atoms. Check the overall charge, 4 minus on this side, and you have 3 minus and 1 minus here, so that's okay. So this equation's done now. Let's have a look at this. This is -1. This is, for oxygen you have a -6 in total, so this has to be +5 to give you an overall charge of -1 here, right? So bromine bromide goes from here to -1 oxidation state to +5. Okay, so this has to lose 6 electrons. Be careful with this one. So going from -1 to 0, 1 electron lost already, and then it has to lose 5 more electrons, so it's 6 electrons lost. That's the difference from here to here. Also you can look at just the oxidation number. Okay, so that gives you 6 electrons, right? Now look at the overall charge. -1 minus 6, that gives you -7. Here you have only -1 overall, so -1 overall charge. Here you have -7 overall charge. So that means this is less negative, so I have to now add OH minus ions onto the left hand side because it's alkaline condition, right? Now also notice there is no oxygen here, so I have to add OH first to start with. Okay, so I'm going to add 6 OH ions. You know why that is? 6 minus plus that minus gives you 7 minus, and you have 6 minus and that one 7. Now the charges are okay. However, the oxygen atoms, check 6 oxygen. You have only 3 here, so I have to add, and this is no hydrogen, so I have to add hydrogen on this side. Divide that by 2, so that gives me 3H2O. Right, now check the oxygen atom. 3 and 3, 6 oxygen atoms. Hydrogen is okay, overall charge is okay, 6 plus 1 7, everything is okay. So that equation is done. Now all you have to now do is make the electron numbers equal in both half equations and come up with an overall equation. Okay, so that's the tidied up equation from the 2 half equations given here. Reduce the water from 4H2O, 3H2O, so you're left with 1H2O on the left, and so on. Done the same with the hydroxide ions. There's 8 here and 6, so I put 2 over here, and the rest of it is there, right?